Hi. So today I want to take you through the peer review process in peer-reviewed journals and how to find articles in peer-reviewed journals. And then you'll do an assignment which you'll carry out outside of class on finding some articles that are peer-reviewed in a peer review process library type exercise. But first, I want to talk about why we have the peer review process and what it's all about. So in general, what we do in science is we follow the scientific method, okay? And the scientific method consists of seeing something and wanting to know how it works, forming a hypothesis, and then a prediction based on your hypothesis about what might be going on. And then you design an experiment to test your hypothesis, because in science we want everything that we say to be backed up by real data and real evidence, not just thoughts or ideas. So once you carry out this hopefully carefully designed experiment, then you analyze the results of your experiment and see if your conclusion is valid. Now, science is an iterative process. We build upon the work of others. And it's also very important that you disseminate your results to the broader scientific community so they can look at your results, see if they can replicate your results, and see if they think that you conducted the experiment well. If your results can't be replicated, then the experiment isn't considered valid. And when I say if they can't be replicated, I mean replicated outside of your lab by someone else conducting an independent but very similar experiment. Okay? Also, it's important to just get the knowledge out there so that people can learn, even if the experiment isn't totally valid, learn from your mistakes. So it's very important to disseminate your results or publish them somewhere so that they can be viewed by the broader community. So what we do is we submit to these journals, which are peer-reviewed journals. Okay? We don't go directly to the press because lots of times there have been in history cold fusion comes to mind. Some examples of things that turned out not to be valid, they generate a lot of hype, and then other scientists review the work and they find out that it's not so great. Now, the peer review process that I'm about to tell you about has only been around for about, I don't know, between 50 and 80 years. In fact, some of Einstein's greatest work didn't go through the peer review process as we know it. Of course, people read the work and tested his hypotheses, but they didn't have to go through the modern peer review process with the journal. In fact, there is a historical evidence that Einstein got actually pretty mad when one of his papers went through the modern peer review process, and he's like, well, I'm Einstein. I don't need my stuff reviewed by this guy. Who is this guy? But then it was found out that some of the criticisms that the anonymous reviewer raised of Einstein's work were valid, and he went on to correct those when he submitted them somewhere else. So it was pretty amusing. But anyway, I'm kind of digressing. Let me get on to what the peer review process is right now. As you can see from this little cartoon, a lot of scientists do find the peer review process quite painful. It is sort of a slow and grinding and painful process, but we all partake of it, so let's move on. So the peer review process is basically, you've done your experiment, you want to publish your results, okay? So you know that you want to submit to this particular journal, which a lot of people in your field read. And by the way, there's thousands of peer-reviewed journals for a lot of different specific subfields. But you choose one, okay? And then you write about your results. That article, once you submit it, usually online these days, goes to a journal editor, and then they do a first pass review of it to see if it's even somewhat valid. I imagine that these poor editors get all kinds of kooky stuff. And if it falls within a reasonable level of non-kookiness, okay, then they send it out to peer reviewers. Usually somebody that you probably know, honestly, if you've been going to conferences, that's within your field, that has expertise in the same areas or similar areas that you do. Usually 2 or 3 people. And then they read it and write up what they think of it and then return it to the editor. Okay? And then the editor sends those reviewers' comments back to the back to the person that wrote it. Now, these reviewers' comments could include a recommendation to just accept the paper as is, but honestly, that never, ever happens in my experience. Or to accept the paper, yes, but after some changes were made. Sometimes those changes can be as simple as their grammar's not too great, make sure they review it, their formatting requirements, they didn't meet them, make sure they fix that. Those are relatively minor changes. Or it could include all the way up to, pardon me, I'm sorry. Hi, sorry. That's the way my life is going lately. So anyway, they can accept with changes. Sometimes those major changes can be up to and including having a whole new set of experiments that they want you to run. Anyway, that's the way it goes. And so then you make whatever changes they suggest, or if they reject it outright, which is also an option, you just decide to start all over, maybe apply to a new journal to publish your results or something like that. But if you fix everything that they ask you to fix, then your article meets the editorial standards and it's published in the journal. So that's the peer review process. Now, why is this important? Why do we do this? Well, first of all, it helps filter out bad science. Oftentimes, if the science is super bad, the editor will get rid of it just straight off the bat, and it doesn't make it into any peer-reviewed publication. Things like this, and this happens a lot more often than you think, include, you know, that whole quantum mechanics thing. We don't really need that. We have a grand unified theory that I've devised that doesn't even, you know, need to explain quantum mechanics. It's all classical. I get a lot of these emails. I know what they're like. That kind of stuff gets shunted off to the side. Perpetual motion machines, stuff like that. But second of all, for legitimate scientific work, sometimes, and this has been my experience as well, the peer reviewers will make suggestions that really do improve the work. They say things like, have you thought of you know, trying this formula, or have you looked into so-and-so's work because this person's work really sheds some light on your work? And you go, oh, gee whiz, no, I hadn't thought of that. And then you fix it and the work becomes a lot better. It also helps to keep the readers of the journals interested. You have to understand that each one of these journals that you look into, they have a very specific set of readers, and if your article doesn't fit with the interests of those readers, then it shouldn't be published in that journal. Maybe it should be published with someone, you know, somewhere else. It helps you keep up with new trends, okay? So if you're a reviewer, for example, you can go, oh, look, we're getting a lot of articles on this now. This is obviously, you know, an area where you got some hot topics going on, so it helps you keep up with new trends. Okay, so what are some of the major peer-reviewed journals within physics? Okay, well, first of all, probably the pinnacle of success, I guess, for any scientist, no matter what their field, would be to publish in something like Science or Nature. And those are interdisciplinary journals that show only the most important work for whatever field. So if you're a scientist, this happens, you should be interested. So even if I have nothing to do with DNA, for example, if there's some DNA work going on, wow, you know, it's really important. They've sequenced it. Wow, that's really important. It goes in Science or Nature. And so if you've done something within physics that's of interest, for example, to a biologist, then that's a really big deal. All right, but within our specific area, which is physics, the physical review might be probably the best. And then of those physical reviews, there's A, B, C, D, E, and so on and so forth. And those appeal to specific disciplines within physics. But there's also the physical review letters, which is of interest to all physicists. So that's some really well thought of peer-reviewed journal. If you're in astronomy, the Astrophysical Journal or the Astronomical Journal are really important peer-reviewed journals. But to be honest with you, there's tons of them. There's tons of these peer-reviewed journals. And then they have different importance levels. I guess within our genre, we call them impact factors, okay? And if you have a higher impact factor, then it's a more important journal. So you just kind of pick where you're going to publish your work. And I'd also like to say that a lot of times these days, physicists are publishing things that are not within physics. So they're publishing in interdisciplinary journals. But by definition these days, physics is multidisciplinary. We work with chemists, we work with biologists, we work all over the place. And that's the way that science is moving. Okay. So, for you as a student, where you are right now is you need to check your references. Okay, so when you're writing these papers for 2210 and 4210 and physics literature and all these courses that you're in, or if you go out and you get a job in industry, you need to make sure that the information that you're getting is reliable. So let me give you a rundown on some of the areas that you can look into from lowest reliability to highest. So lowest reliability would be personal websites. And emails and all that stuff. People can post whatever they want, direct, total crap on the web. There's no filter, okay? Like I said, I get emails every day directing me to some website saying that, you know, they thought of a new grand unified theory that doesn't include quantum mechanics, or that they thought of a great perpetual motion machine, and that thermodynamics is wrong, okay? People can publish crap on personal websites, and it doesn't mean anything. So basically don't believe anything that you get off someone's personal website, okay? Only slightly higher than that, I'm sorry, I know, is Wikipedia. I love Wikipedia too. I use it as a starting place all the time, but I do go on then to check my references, okay? The reason is that anybody can get on there and mess with Wikipedia. Okay, I can get on there right now and write a Wikipedia article, and I could make it intentionally wrong, and don't think that people don't do this. Okay, they do. So you need to double check it with more reliable sources. Okay, slightly higher than that are websites that are sponsored by universities or government labs. Again, there's no peer review. There's probably not too much checking going on of this. So you need to verify the info elsewhere, but at least you know that the information is supposed to be coming from someone that has the proper background and education in the field and knows a little bit about what they're talking about. And also these sites, like the one that I show here on the right is the National Institute of Standards and Technology website, they're going to give you links that might be references to peer-reviewed journals or textbooks or other articles, and that can be very, very useful. Okay, slightly higher than that would be the non-peer-reviewed magazines where the articles are written by journalists, okay? These include things like Discover, okay? So journalists, they do their best, and lots of times the scientific journalists these days have degrees, undergraduate degrees in the field, okay? We've had some people from out of state that have gone on to be scientific journalists. But what they're doing is they're interviewing the scientists that have done the work, and then they check it. And oftentimes they'll run it by the scientist, but sometimes not, okay, if they're on a deadline. And most of the journalists aren't going to be professional scientists. So they're going to do their best to give you the full story because it's their job if it's not right. But you can't 100% rely on them because it's not coming directly out of the mouth of the scientist. Okay, slightly higher maybe than non-peer-reviewed magazines would be open access papers, okay? There's been a lot of press about this lately. If you Google open access papers, there's a lot of people complaining about them. And one of the reasons is lots of times they say they're peer-reviewed, but they're not really peer-reviewed because they're getting money being paid by the scientist to publish the paper, okay? You have to shell out as a scientist a few hundred or a few $1,000s to get your paper published on these things. And so to make their buck, what they're doing is they're just publishing and oftentimes not checking stuff. Some of them are more reliable than others, depending on the publisher, but you still need to check these references. Okay, slightly higher than that would be non-peer-reviewed magazines and journals where the contributions are written by the scientist oftentimes. This is first-hand information. Lots of times they've had to dumb it down, but it is first-hand information. I include in this Scientific American, okay, and Physics Today. My PhD advisor actually wrote an article for Scientific American one time on friction, and so it came directly from her. Now, yet again, the peer review isn't as rigorous. It's being read by the editors at the magazine, not by other scientists before it's published. But at least somebody's checking it to some degree. Slightly higher than that is textbooks. The info isn't really wrong most of the time, but lots of times it is old, okay? It's old news by the time it makes it to a textbook because it can take a couple of years sometimes to get from the writing stage of the textbook to the publishing stage of the textbook, and so lots of times the news will be old. And then of course the highest in the hierarchy would be peer-reviewed journals. That's going to be new information, current information. It's been peer-reviewed. Now that's not to say that it can't be wrong, okay? Because science The scientific method is a process of constantly checking and revising your hypothesis, refining your experiment. And so lots of times experiments that are accepted at first are then gone on to be proven wrong, but at least they're doing their best. Okay? Now, you might be saying, okay, well, this is all well and good, but I've never read a peer-reviewed article in my life, and I wouldn't know how to find one. Okay? So I'm going to, in the next part of this lecture, take you through how to do that, and then you'll have an assignment where you're supposed to find some peer-reviewed articles and upload them. Our library actually has several search engines that will only return peer-reviewed articles from your queries. Okay, so this helps you find peer-reviewed articles. The one I'm going to focus on is my favorite, and it's called Web of Science. Google Scholar is also a nice option. So if for whatever reason later on in life you graduate, you move on, Google Scholar is available to everybody. Whereas right now the library is paying for access to Web of Science. Okay, so you might not get that once you go on and you're not at ASU anymore. The library also has a lot of subscriptions to peer-reviewed journals. They pay thousands of dollars a year for their subscription to these peer-reviewed journals. And these journals and articles are available to you at no cost online, so you'll be able to access them while you're here. Okay, so how do you do it? Well, first of all, you go to library.appstate.edu, which is the library's homepage, and then if you want to search Web of Science for a peer-reviewed article, you go under Find, and you click on Article Databases and E-Research Tools, right there where I've highlighted in red. Okay? The article databases will lead you to the search engines, which can help you find the article that you want. Once you click on that, I'm just going to help you find Web of Science. Okay, so I know what the name of Web of Science is. It starts with W, so I click on W. But if you're not sure, if you've forgotten or whatever, you can go down here by subject, okay, and then there's actually a link for physics and astronomy, and that'll lead you to several databases which might be of use to you. But like I said today, I'm just going to stick with Web of Science. So we're going to go on. You're going to click on W for Web of Science. And then that'll bring you to databases by title W, and you click on Web of Science. Okay, now you're at the Web of Science portal. Okay, so now you're going to do a basic search. Presumably, you know what you're looking for. You want articles on a specific topic. Okay, so the topic that I'm going to use as an example is organic semiconductors. Okay, so I do a basic search, and I type in organic semiconductor, and I've highlighted by topic. Okay, you can also choose by author, by journal, whatever you like. Okay, so I've chosen organic semiconductor. You can also choose by title. So if you know the title of the article that you want, you can look it up that way. Okay, now organic semiconductors, huge field. So when I typed in organic semiconductors and hit search, it returned about 19,000 articles. Now obviously, I'm not going to page through and read the titles in the abstract for 19,000 articles. It's just too much. So over here on the left-hand side of the page is an area where you can refine your results. Okay? So you can either type in search within results for, and then you type in more under topic that'll help you find what you're looking for, and then you hit the little magnifying glass here, which will do the search. You can search by document type, or you can search under category. Okay? What I chose to do was to search under refine results and narrow it down a little bit. So I decided that what I wanted to search for was work done with an atomic force microscope, because that's what I use, and also work that was going to be applied to solar panels. Okay, so I searched for solar and subtopic atomic force microscope, and now see I got 99 results, which is a much more reasonable number. Okay? Now, let's pretend for a second that what you're doing is you're a student and you've been asked by me or Dr. Conrad or somebody to go and find out all you can that's going on in a field. Well, in that case, you might be interested in a review article. Okay? What a review article does is it summarizes the work of a whole bunch of different scientists and a whole bunch of different experiments. So here, document type, okay, I clicked on review, okay, for a review article. Now, you could also do a regular article, and a regular article is going to be something where somebody has written up their own experiment, just their one experiment, or you could go to a proceedings paper, and proceedings paper are things where they published a paper associated with going to a conference. Okay, so you could refine your results that way if you want. Like I said, I chose review article. Okay, now there were 3 review articles, and here they all are pulled up. So heterogeneity in polymer solar cells. That was the one I was interested in. That looks like a great article. Okay, so now I want to know what's in that article. I want to access that article. So you can see underneath there's some buttons: view, full text, or view abstract. Okay, you read the abstract oftentimes, you know whether or not you want to read the full paper. That's what an abstract is for. But let's say that I've been looking for this particular article and I want it. So I click on full text. Now when I click on full text, here's what happens. This Find at ASU icon pops up when I click on that, and that's what I want to do. I want ASU access to that article. So when I do that, I click on Find at ASU, and this comes up, okay? This is the article. This is the portal to the article. It's published in a journal called Accounts of Chemical Research. Like I said, things that are of interest to physicists are often published in journals that aren't specifically physics these days, so that's not all that surprising. So now I look here and I see that there's an article, ACS Active View PDF. So what that'll do, if I click on the PDF, is that'll pull up the article, the full article, as a PDF file, and that's what I want to do. So I went ahead and clicked on PDF, and here's my article. Okay? It pops right up in my window, and I can scroll down and I can read it, or I can print it out, or I can do whatever I want with it. So success, okay? I've gone through the process of searching for a particular article, and now I've found it, okay? So what your assignment is going to be today is to go through an exercise where you look up all these different articles, and you try and find the specific one. Okay, so here's the exercise. It's underneath the lecture that I've just posted online, and it's called labexercise.doc, okay? So what you're going to do this week is you're going to go through these things, and you're going to find out which of these headlines is backed by real science and which is backed by science fiction, which I made up, okay? So there's 8 or 9 articles here, all right? Now the titles are not real titles. I totally made them up. Okay, I made up all the titles, but that doesn't mean that the science behind the titles isn't real. What I tried to do was I tried to make it sound like a Weekly World News headline, so you weren't sure which ones were real and which ones weren't. So the first one, for example, is never before found experimentally. Scientists isolate magnetic monopole. And I need you to find out if that's real or not. Now what you can do is you can go through and do searches on the web, just regular Google or whatever, and see if you can find anything about this. Once you figure out, based on the web, whether you think it's true or not, what I want you to do is then use Web of Science or Google Scholar if you prefer, I really don't care, to find the reference for the peer-reviewed journal article that discusses it. All right? So I want you to find the actual reference. So the reference would be, for example, for our accounts thing, you need to give the journal that it's in. For example, Accounts of Chemical Research, you need to give the title, you need to give the author list, you need to tell me what page of the journal it appeared on, what volume, and what year. Okay, so that's the full reference for that article. Okay, and if you're confused, you can always find the article and scroll down to the end where they give the references, see what a full reference actually looks like in their bibliography, and sort of duplicate that, okay, for the article that you found. So that's what I need you to do. Okay, now, after you've done that, and you can just type in on this particular document what the reference is after each one of these, or if it's not a reference, you can type in and say that it's not true. Okay, so you can take this Word document and just add to it and edit it yourself. It's fine with me to do that. Then, once you've done that for all the ones, what I want you to do is upload a PDF file of one of the articles. You don't have to do it for every single one, just one, okay, just one. Upload one PDF of the full article for one of the guys that you found. So you're going to upload in total to the assignment 2 documents, okay, a Word document telling me whether they're true or not, and if they are true, what the full reference is, and then also the PDF for one of the true articles. All right? And that's your assignment for the week. Now, it's easiest, honestly, if you work at an ASU computer, Okay? Or if you're using your own laptop on ASU's campus through the wireless internet here, then the library will automatically recognize that you're an ASU student. If you do it from home on your home computer, what you'll have to do is you'll probably have to enter your banner ID at some point, because what will happen is when you go to Web of Science, it'll go, hey, wait a second, are you an ASU student? Because we're only paying for ASU students to do this. And so it'll ask you for your login ID or your full name and your banner ID, and you'll have to enter it there. The connection also might be a little slower if you try to do it from your home computer. That's not to say that you can't do it at home. You certainly can. It just might be a little easier if you try to do it on campus. But whatever, I'm good with that. Okay, so you have 1 week to do this assignment and to upload it online. It's going to be a fully online assignment, and good luck. And if you have any questions or if you get stuck, as always, feel free to drop by during my office hours and ask me for help. Thanks.